Solve the system. Solve the system. That sounds like some, I don't know what that sounds like. Solve the system. The system's broken. We need to solve it. Whatever. We're talking about a system of equations here, and here's the system of equations we're looking at. And this is set up for, I think one of the most straightforward methods, which is substitution. So the thing I just highlighted is equivalent to y. And why do I know that? Because that's what this equation tells me. It says y is the same as x minus 7. I'm going to use that value of y in my first equation and perform, simple substitution. So that first equation, when I do the substitution, looks like this. You can see there's a positive 2x and then minus the quantity of x minus 7. So you can see I just subtracted all of y. That's y. So I have 2x minus what y is. Y is x minus 7, and that equals the number 9. So an application of the distributive property, right, there's this negative 1 I need to distribute across this subtraction problem. I get that 2x minus an x plus 7 is 9. 2x minus x is simply x plus 7 is 9. So x is going to be the value you get when you take 9 and subtract 7. And the last time I checked, I believe that's 2. 7, 8, 9. Sure. Okay, so there's part of my answer. I haven't solved the system, but I do know that x is going to be the number 2. Now, figuring out what y is fairly straightforward. You can see I have this beautiful equation, the second one, that tells me exactly what y is when you know x. It says, hey, y is going to be x minus 7, which is amazing because I just figured out what x is. It's 2. So if I plug this value in for x in this equation, I get y equals 2 minus 7, which looks like y is the number negative 5. And that is my solution. It's at 2 for x and negative 5 for y. And I definitely checked that. I plugged it into the original equation. But for here, I'm just going to write my answer as an ordered pair. Always x, comma, and then your y value. So there's the solution. That's the point where these two lines cross each other.